Hi everyone, good morning. Nice to see you. This is the webinar of the AUTOFLEX and the FOREMAST project. My name is Jonathan. I'm the dissemination manager of the FOREMAST project, and I'm happy to see you here today. So what we have on our agenda today is that we would like to introduce to you guys, if you're not familiar with that yet, the AUTOFLEX and the FOREMAST project, two projects working on autonomous vessel and automation of the logistic process. We have people that are involved in the projects and developing some solutions for automation and automated transport. And I would like to introduce everybody. So from ABB, located in Krakow, we have Michal Smolana. Good morning, Michal.
Morning.
We have Georgia Sioshantari. She is the project coordinator for the FOREMAST project.
Good morning, everyone.
Good morning, Georgia. Then we have Jerome Favre. He's from Bureau Veritas, located in France. He is part of the AUTOFLEX project as a member of the advisory board. Good morning, Jerome.
Good morning.
Then we have Mats Benson-Billester. He is part of DFDS and working for the AUTOFLEX project. Good morning, Mats.
Good morning, all.
Odd Eric Merkrit, he is the project coordinator of the AUTOFLEX project located in Trondheim. Good morning, Odd Eric.
Good morning.
And then we have Maria Chiara Borda. She is working for CFAR and they are part of the FOREMAST project. Maria is located in Antwerpen. Good morning, Maria.
Hello, good morning.
And then also from the organizational side, but more included in doing some Slidos and getting you interacted here today is Javier Rivas. He is also from the FOREMAST project. Good morning, Javier.
Good morning, everyone.
So as announced on LinkedIn, and I'm pretty sure most of you saw the that this webinar is happening today on LinkedIn. We are looking forward to have a discussion, an actual discussion, and not just presentation of slides where we're all not along. So if you feel comfortable, you can turn on your cameras later on or right now. You can also turn on your microphone and ask your questions. But to make it a little bit more organized, it would be really helpful if you post the question in the chat beforehand and give a little indication that you would also like to ask them personally by turning on your camera. So if you agree to that, you would also need to click on an agree button because this webinar is being recorded. You can also check it out later. And yeah, we would be very happy if you have some questions or you would like to give your opinion or say something about your experience about automation process on automated vessels and the whole logistics chain and how inland vessels can change and inland vessel transport could be more prominent and useful. So let's get started. We'd like to get to know you a little bit. Javier, would you please prepare or show the first round of Slidos? So yeah, just simple questions. You can attend by putting in that code that you see in the bottom left corner and put it in on slido.com, or you can scan the QR code and join with your mobile phone. It's as simple as that. Yeah, and then whenever you're ready, Javier.
Good morning. I will leave just 20 seconds more or less just to allow people to join Slido. So there will be 3 questions in this first round. So I hope you are all ready to start with the first question. That is, how familiar are you with the concept of autonomous inland vessels? So very familiar. I work on it. Somewhat familiar. I've read about it. Very familiar. Heard of it, but don't know much, and it's new to me. So far, we have all the people that have replied that somewhat familiar or read about it. So if you agree, I will go.
I guess people are a bit shy today. Maybe is it working for you guys? I hope so. If something is not working, please give us an indication.
We'll give some more time to the people to join the Slido because, as you said, there is just one person that has replied.
Do we need to
So
confirm? Do we need to confirm our answer? Because I see only one reply on the top right.
That's correct. Yeah.
Response. Yeah. I think you need to fill in all three the answer or the questions and then submit.
Yes,
Oh, that's how it's done.
you
Okay.
have to send.
we have a second person that has replied. Has someone problems to join Slido? Or is everything okay for there? Now I see 4 people. Okay. 5 people. 6. 7, 8. Nice. Thank you.
Okay, now I think we almost got everybody. So in total, there are 13 people and 9 already answered. Thank you for your participation. So I guess, Javier, you can take it from here.
We go for the next one. Okay, you have all replied the 3 questions, I see. Okay, so what are the logistics will be benefit the most from automation and autonomy? So we have same 5 people have replied to short sea shipping and the other 5 to last mile inland transport. And intermodal integration as well. We have some people port operation and environmental footprint, but the main are short sea shipping and last mile inland transport. And for the last question, in one word, what is the biggest opportunity autonomous barges bring to Europe? So we have reduction of the human involvement, not clear at the moment, small transport on non-time sensitive cargo, integration, and seamless. More replies to this question. I only see five people that have replied so far.
Okay, not so far in the moment, but it seems to me that most people in the audience are active in the field of autonomous shipping. And they also they kind of agree on that autonomous shipping will have last mile delivery or short sea shipping. I guess this is something that AUTOFLEX and FOREMAST are both working with. And I think it's good that you joined here today so we can introduce our approach. See how you if you agree on what we're doing and what we're aiming for. And I guess to get a better idea of what AUTOFLEX project is about, I would like to give the stage to Odd Eric, and he will present the scope of the AUTOFLEX project.
Yes, thank you, Jonathan. I will present the scope of the 3-year project in 5 minutes. So that's an interesting challenge, which I will try to answer to. So instead of going into like regular presentations on budget and partners and all these things, I think we'll jump straight into it. What is the AUTOFLEX project about? As you might be aware of, it is a Horizon Europe project. And the main objective of the project is to develop small uncrewed automated zero-emission vessels for inland waterways, and to also demonstrate inland autonomous navigation in the end of the project, the full-scale demonstration. And we will also look at are looking at the large-scale automated, what we call zero-emission transport system, which I will come back to. So one of the latest news from our project is the new vessel design, which is a SEMP2 class, which is a rather small vessel. The SEMP2 is one of the smallest canal classifications in Europe. It's a 53-meter long vessel. It has a capacity of 22 TEUs. That is 20-foot equivalent units, containers. It is based on what is called Oscar Teubert class, which is a class design of SEMP2 barges from the 50s. So we propose this as Oscar 2.0. And we combine modular energy systems like containerized batteries from zero emission services in this case. We combine that with automated operational features from Maritime Robotics, who is delivering the autonomous navigation system for this vessel. So they are delivering some of the key sensors and positioning systems for enabling autonomous navigation. It also has a full electric propulsion system driven by the CES pack, the containerized batteries. So we have 2 electrically driven azimuth thrusters in the stern of the vessel and a tunnel thruster in the bow, making it fully activated for autonomous navigation. So how do we actually fit this into the transport system to enable the modal shift? Well, we have a use case in the Randstad region in the Netherlands, around the very densely populated cities on the western coast here to the left in the picture. And to the right, you can see the existing network that is being used. This is in the waterways. So to the right, you have the bigger classes like SEMT6, where there is a lot of transport today. But on the left side, there are the SEMT2 class, which is today considered too small for efficient cargo transport. So that is why we have chosen the SEMT2 class to try to do something with the underexploited canals by utilizing our new vessel design. So on this map, there's a lot of symbols, but this is basically showing all the locks and movable and fixed bridges. There is one specific fixed bridge in the Den Haag area, or is it Delft is it? Where the bridge is actually so low that you can't enter below it with 2 tiers of containers on the vessel. So that's also something we need to look into for our concept. To enable this, we have what I call the zero emission transport system concept. There are 3 building blocks there. Basically, it's the stow and charge, which is a concept that includes production and storage of energy, with facilities for swapping these energy containers and also for efficient cargo transshipment. We will look at where we should put this in the transport system to make the logistics in general optimal, considering transport capacity and also the range of these vessels. We have the temporary port terminals, which is considered to be a flexible concept that utilize keys that are there already that are not in use for different reasons. So we will explore how this infrastructure can enable a minimal investment and how it can be made mobile. In the end, the mobile distribution centers, which could be containers that you put in the city centers where people pick up the parcels and stuff. And we're looking into different ways of developing that. And then just want to end with our key exploitable results. I mentioned most of these already, but the ones that I have not mentioned are business plans and the Seaguard tool. I think business plans speak for themselves, and our partner DFDS and Mats will talk more about that. The Seaguard tool is being developed by the NTUA, the National Technological University of Athens, which is a tool that is real-time monitoring the safety state of the vessel. So that's also linked to cybersecurity and the general situation of the vessel. So if there are failure situations on sensors and all these things. By that, I think I've spent my 5 minutes, Jonathan.
They're over, yeah, definitely, but
yes,
you managed
okay.
to stay in time, so I guess it went all right. Thank you, Odd Eric. Thank you for introducing the AUTOFLEX project and what we are working on. I don't see any questions in the chat, and I will just leave it at that. So if you need any more information, just let us know, and then we can talk about that. And since there are no questions, I would like to to give the microphone to Georgia, and she will introduce the FOREMAST project, and then we will learn what the projects have in common and maybe also what they have in difference.
Okay, give me a minute. Okay, can you see my screen?
It looks totally fine.
Okay, great. So I will try to not use more time, like what Derek did. So, okay, I will skip this. I will go into the project specifics. So, both projects are quite similar, actually. So in FOREMAST, our mission is to develop and prototype small, flexible, automated zero-emission vessels, or SFAS vessels in short, to revolutionize how goods move in urban and coastal areas. At the heart of our concept is the combination of realistic automation with green propulsion and innovative ship design. So here, I don't know if you can see the next slide. Okay. I can briefly explain you what SFAS stands for. So SFAS vessels are small because they are designed to navigate in narrow, shallow waterways. Flexible because they provide modular and multi-purpose operational capabilities, including cargo adaptability and dynamic platoon strategies. Automated. Here we are talking about partial or full automation in navigation, docking, and fleet coordination. In this way, we pave the way towards fully autonomous vessels with consideration around regulatory framework. For this point of automation, which is the point, the topic of today's webinar, my colleagues from ABB and CFAR will provide you with more details a bit later. And finally, zero emission, because we are using battery electric propulsion, hybrid systems, and green infrastructure to meet tightening emissions regulations. So we have 3 living labs in total in our project. For our first living lab in Ghent, we are retrofitting the Avatar vessel for urban goods transport. This vessel is equipped with CFAR's AI-based remote navigation system to improve the situational awareness, and also from PELS, it's a partner of our project, flexible battery electric or hydrogen energy module. So this setup is being tested in real business cases, like moving construction materials and soil from the Opera House renovation site. Our second living lab is in France. Here we are testing an innovative 3-hull vessel design, vessel prototype for urban freight transport in Caen. Sorry about my French. The vessel is under 10 meters. And it is designed by one of our partners, University of Galati. University of Ghent is running full-scale maneuvering trials to feed automation models, while ABB provides a modular control system enabling advanced human autonomy collaboration. In this living lab, we are balancing real-life trials in Caen with simulation work in Le Havre. And the final one is a virtual living lab, actually. It is in Galati. So here we are using the RexDan research vessel for data-driven modeling and targeted testing. The emphasis here is on understanding how our innovations can transfer across diverse regional contexts, linking research with broader applicability. About our peers, I think Javier will say a few words later. This is from me.
That was rather quick. You were saying
It
that
was
you need
quick.
some more time, but that was really
I
great.
didn't
Now
check
it's
the
fine.
time.
Thank you, Georgia.
So kind.
If there is anything to add, you might also take 1 more minute. You good? All right. Yeah, thank you very much, Georgia. So I think we got a good overview of what the projects are about. They are sister projects, so they are funded from the same call. This is also why we are collaborating, because we're having some same objectives. We're working in similar areas. We also have and use case, what we call it. This is comparable to the Living Lab from the FOREMAST project in the AUTOFLEX project. So there are some overlaps in topics, and yeah, but as you also have heard, there are some differences in the vessel sizes and what we're aiming for and how to establish a modal shift in the transport system. I don't see any questions in the chat. I would continue now with Mas. So Mas is part of the AUTOFLEX project. DFDS is a logistic company. And my question before you get started with your presentation, Mas, what is the challenges you are tackling within the AUTOFLEX project? So what is there something you're working on that is not so easy to do maybe in your everyday life?
Yeah, thank you, Jonathan. It's a good question. I think primarily it is to engage with all relevant stakeholders and parties developing this. The partnership part or the cooperation part is key to solve it, to get all the right people around the table and progress together. So not one. The funny thing about autonomy is that you need to have a lot of people online and they need to take a step at the same time, which is super difficult. And I think that is what we are trying to do in these projects, both this joint event with AUTOFLEX and FOREMAST, but also in general in these projects. So we are trying to take that first step together in a synchronized way.
Great, sounds good. I can already see your shares, your screen sharing, and then maybe you can continue with the presentation. We can hear you fine. The stage is yours. 5 minutes for you.
Thank you so much, and really good to meet you all. My name is Mads Billesø. As just mentioned, I'm heading the Innovation and Partnerships Department in DFDS. Some call it the Radical Innovation Department, and we're working on green transition, alternative fuels, electrification, and so on. And also also autonomy, and that is going across the entire operation. I have brought up a map here of the DFDS network. We are covering all of Europe. I have 18,000 colleagues. We have 75 short sea vessels, plus minus. And interesting here is that our vessels or our assets in general are super busy. On the vessel side, we have more than 35,000 arrivals and departures every day or every year. So quite busy. We are including a lot of different modes of transport, which is also interesting, and what we kind of see in the AUTOFLEX Corporation is that we're looking at this multimodality and how different assets meet. So this is what we primarily move in DFDS. This is the trailers. On land, it is moved by the truck in front. In more and more cases, it is moved by a battery electric truck, and we are trying to explore that further. We have the terminals where the land-based operation meet the sea and the inland waterways. This is the Rotterdam terminal called Vlaardingen. We also have some warehouse facilities there. Then we have the short sea vessels, different kinds. Some of them can take passengers, some of them are primarily on cargo. Most of the vessels have voyages less than 24 hours. So it is a kind of short sea operation. And then, of course, we are in a higher and higher degree using other modes of transport when doing the last mile, first mile, and middle mile move. And for many reasons, green transition, congestion, and so on. So a lot of reasons to further develop the inland waterway transport, the rail networks, and other areas in the DFDS network. We see ourselves as an integrated logistics provider. So we are moving from door to door. Most of our customers are contract logistics customers, so larger volumes of cargo, larger amount of units every day or every week. So it is also in that way predictable and something that we can bring into these projects on cargo flows and for the greater analysis. This is the Sorrento barge that we are currently operating out of Ghent, primarily to Antwerp and Rotterdam. And it is also the barge where we are working on the data available from inland. It is a EMT class that is rather high, so a little higher than the vessel that we have developed in the project, but still very relevant in that case as well. This is our terminal in Ghent, where everything is actually meeting in this terminal. We have a rail connection. We have short sea on the short sea vessels on the right side going to the UK and to Sweden. We have the inland that both mainly transporting containers, and we kind of have everything in this picture on this multimodal transport network, and also the port that we are engaging on in the AUTOFLEX for the demonstration case. Autonomy alone on inland makes some sense. If we really need the big impact, we need to include the port operations. We need to include kind of all the different processes moving a cargo unit from one location to another. This is the award project that we concluded last year, developing autonomous yard tractor together with Turberg. We did that in Rotterdam for the demonstration case, and we actually took it all the way from public road and all the way on board the vessel in the end. This is a trailer, but it could just as well be a chassis with a container on top, and that is what we are trying to engage in new projects. We also have trucks on the roads. This is a truck from the MODI project with Volvo, and autonomous transport on public roads, also connecting to inland again. And then we have the Zealandia Seaways, where we're working on short sea shipping or autonomy in short sea shipping. So everything is also kind of moving in this space, and we're trying to use all the knowledge and the experience that we gain in these different projects. Overall, I would say that these are kind of the key elements in making autonomy happen. Autonomy started as kind of moving people away from operation from a safety and health perspective. It soon moved over to reducing cost, and a lot of the kind of the business cases that I've seen is only looking at the reduction of FTEs, which will not make many cases happen. Some cases will, but in reality, we need to include all of these different drivers to actually build the cases, and that we are trying to do both in AUTOFLEX and other projects. 6 of them, the ones on the left and in the top, are kind of pulling us as an industry player into utilizing these autonomous systems. The one in the lower one, I imagine that will be the one that will actually push us the rest of the way. We are lacking people in general, more than 80,000 truck drivers on land just in the EU, a similar number in the UK, and it will just increase the shortage over time with the increased volumes that needs to be transported. So it is super relevant that we engage on this. We have the technology development. We're working on regulation and the cooperation between the different parties to make this happen. And hopefully we can with these projects we can speed that development and the adoption up. Often we look at it as binary. Either it's a 0 with 0 people on board or in the truck, or it's a 1 with people on. But there's a lot of steps in between, and that is also what we are trying to do, is to have this staged approach where we see benefits already on step 1 and not just on the kind of the final step. So that is also really important for us in these discussions, how we can phase this approach and build while we are getting the benefits. So that was a quick word from one of the industry players. I'm super happy to be here and engage in the dialogue with you later. Thank you.
Thank you, Mats. We're also happy that you are here today, taking the time. Thank you for showing us some aspects of what DFDS is doing and how it's overlapping with the AUTOFLEX project. And also, yeah, touching upon the topics that were also interesting for the audience, short sea shipping and last mile distribution. I think this is something that you are working on. Continuing with short sea shipping, I would like to see the presentation from Maria. She's working for CFAR. And I guess, Maria, it's the best when you explain on your own what you're doing. And maybe the same question for you. What challenges are you tackling within the FOREMAST project that is not really not easy to do for you in your everyday working life?
Yes. Hi, Jonathan. Do you see my screen?
I can see it looks good.
Yeah, thanks. Okay, by answering your question, the main challenge is to synchronize the activities with the other partners in order to ensure that we effectively reach the goals that were set in the grant agreement at the beginning. And for CFAR in particular, and maybe I can add one point after my presentation, is about depth estimation. So before I give the presentation, then I continue to answer your question, all right?
Sure thing.
In FOREMAST project, CFAR is working in the Living Lab 1 in Ghent, and our focus is in enabling the semi-autonomous shipping. So we are equipping the Avatar 3 ship with our equipment for the remote control, and with some advanced algorithms and tools that allow the semi-autonomy. I would like to focus on one reason why the remote control is needed nowadays. Imagine a shipping on 32 hours. In the traditional shipping, you would need 2 captains on board the ship for the total of 32 hours. So you would have 2 captains times 32 hours. The ship owner would need to pay them for 64 hours. While with the remote control technology and with the scenario of 1 captain on board and 1 remote operator, you would only need to pay 1 captain times 32 hours plus 1 remote operator times 2 shifts of 8 hours. This leads to a saving of 25% in cost. And if you go one step further, so with the scenario of only 2, with both captains in the remote office, so 2 remote operators, the ship owner can have 50% of savings. And this is only the purely hard economic value of the remote control technology. But if you look behind the shift, so you see that the remote operator can work for 8 hours and then they can stop and work for another 8 hours the day after. It means that the remote operator, he or she can go home every day. And this is really a radical shift of the work, of the mentality and the work-life balance that the captains can now access to. To go one step further, so for the semi-autonomous part in a FOREMAST project, we're working on improving our object detection model by applying the artificial intelligence techniques that we previously developed in other projects to the to the scenario of an urban dense area, such as the canals of Ghent. And you can see here our algorithm applied to a camera feed from one of the Avatar ship. You can see this little number that is changing. It's the score that we use to evaluate the prediction and the detection. On top of this, we would like to also continue further and develop the algorithm to estimate the depth, the distance from these objects. And in particular, the monocular depth estimation is the estimation based on the monocular camera view. Because the avatar ship doesn't have a radar and we cannot do the other fusion the fusion of other sensors. So we are investigating in this kind of estimation. We also try to compare the results from this estimation with the estimation that we can have with the stereo camera. So it's another technology. And we will see how we will go. If you have other questions, I will be happy to answer them. But to conclude and answer your first question, Jonathan, for CFAR, this monocular depth estimation is something that is really challenging right now for us to understand how we can use the artificial intelligence algorithm and apply it to only the pixels of the image that are of interest. So you have the object detection model that detects the obstacles, so the other ships or kayaks, for example. And we would like to apply it only to the pixels of the detected obstacles. Because for now, what exists is that you apply to every pixel of the whole image, and that requires a lot of capacity in calculating a lot of capacity. So it's very difficult. Thank you.
Okay, so difficult and time consuming. I understand. And it's good to take some time with a new project. Thank you very much, Maria. During your presentation, there was a raised hand by Sifis. Sifis, who are you? Where are you calling from? And I assume you have a question to Maria, so please.
Yes, indeed. So I'm actually working for the Norwegian Maritime Authority, not so much related to inland, but of course heavily involved with autonomous ships in general. I was triggered by the diagram of the shifts, I have to say, where it said that, 8 hours, 8 hours, 8 hours, and then you would have a benefit. And my comment to that would be, I would question how realistic that it is to be depicted as it is, because at least what we see with maritime at the moment is that we need some significant time in order to perform the changeover, so that there is sufficient situational awareness to be gained either by the remote operator or by the captain. And so that there is an overlap. That's my point. So there is an overlap where the remote operator and the master have to sort of deliver and report, okay, everything is fine, or I have this and that issue, and gain some situational awareness before they take control.
Thank you, Davis. I think that's we got the question in the first idea.
Thank you.
I think it's a good question. Maybe it points out the differences between inland and maritime shipping. Maria, could you do us the favor and share the slide from your presentation again, so that everybody can be aware of what Sifis was talking about? So, and then the way I understood it is that Sifis, you are saying, okay, this clear distinction between time being on duty and off duty. There is no clear cut, that you would also need some time where two seafarers at the same time need to operate to have a transition and update the other person. So maybe, Maria, you can tell from a point of view how CFAR is visioning it, and maybe there is a difference in inland shipping.
Yes, I can say how CFAR is managing that right now, and I know that the remote operator works for 8 hours, and in those 8 hours he has to check and to follow a well-defined procedure to take over control, and also to hand over control back to the captain that is on board for now. Or because, yes, for now at CFAR we have 2 remote operators. So if they are working on different ships, the ideal the ideal would be that the first remote operator hands over the control to the second remote operator, but for now we are handovering the control to the captain that is on board. So of course there is maybe if it's not working 8 hours, it's working 8 hours and a half, but it's still better than having the captain on board for all the time that the ship is sailing. So that is the benefit. And
okay, so you're saying that this is kind of an example how to show it here, and the overall working time for one captain would be 8 hours, different from being on board, but there might be a chance that in a given day the working time might be 8.5 hours. This is more a scheme to present it.
Yes, this is an approximation, but I mean, like everyone also in our work that we work with at the office and with screens. Sometimes we can work 7 hours and a half, sometimes 8 hours and a half, and it's an average.
Okay, thank you. Does this answer your question, Sifis? Could you agree on how it's presented here?
Yeah. No, I think it's as I said, I got triggered because it appears so quantitative. Can I ask also something? When the captain is resting, are there any other tasks? Is he on call in case something happens, or there's nobody on board? I just didn't understand that part.
So let's say the change of the position of the people is affecting only the captain. So the captain becomes the remote operator, and the rest of the crew remains on board. This is how we operate.
Maybe we can tackle this topic later on during the discussion round, because we have also planned for talk a little bit about the human factor, talk about how the job of a seafarer or a captain is changing when he's sitting in the rock instead of steering the vessel from the bridge. And then maybe we can dive a little deeper into differences between now and maybe in the future, or maybe also differences between maritime and inland. I would like to continue with the next presentation, more from more technology, and Michal is working for ABB, a technology provider. They are also not only involved in inland shipping, but also maritime. So maybe Michal, you can say a bit more what you are doing, and also what you are doing in the EU project that is not feasible to do in your research work or your technology developments.
Yeah. Can you just confirm that you can see my screen and I can
see the screen and I can hear you fine?
Okay, that's great. What are the challenges that we are tackling within the EU founded project? Because what we are focusing is this shift towards a modular concept of the functionality for the vessels. So usually the approach for very flexible or very small footprint is not applicable or is not the business case for our recent clients that are mainly seagoing vessels, large seagoing vessels. So the customer focus there is the turnkey solution. However, we see the value from actually being able to provide the solution that we can actually adapt to the vessel size, but also to the operational profile that the vessel is, let's say, working on. Because as you mentioned, we hasn't been, let's say, present in the inland waterway, but for us it seems that this is like a very nice thing or very nice use case for us to start actually being this more flexible and provide the functionality that we can actually change and adapt to the scale of the vessel.
Thank you, Mira. Then, after that, I think it's time to see what exactly you're working on and how does it look like.
Yeah. So maybe starting from why we are working on such a solutions in general as ABB. Already Mats and Maria did showed some, let's say, common drivers for the automation and the remote operations as well. So for us, the biggest, let's say, concern that we have heard from our original business was the safety and operation efficiency. So in that sense, if we look on the automated systems that can actually support human in challenges when the situation are critical or there are some issues on the vessel, that's, let's say, one of the points that we would like to address in general, also within the FOREMAST project, which is very specific. We have narrow canals, we have smaller vessel size. Those are usually congested canals or congested routes that there are many of small floating units, kayaks, etc., etc. So this is also the new environment for us in terms of safety. And the second thing is reduction of the emission, of course. That's also the thing that we would like to support in general. So by providing some sort of automation or autonomy in certain, let's say, areas, we can then improve the energy efficiency, and by this we can lower the operational cost, reduce the reliability of the solution in general. Yeah, going to the next, how for us, how today's operation look like. So despite that we have on the vessels many of the navigation technologies or supporting systems that are helping captains to operate the vessel, even though we install all of those fancy solutions, still, even if in let's say very modern vessels, still we're using quite old tools like binoculars to just check and verify if what we can see on those screens, what we can see on the radar picture, if that's true, and if the situational awareness around the vessel is, let's say, valid for us. So still, even though there's like a huge amount of various systems supporting operation, still we are relying on the human or on the human communication. Yeah, so we do have radios, and for instance, in case of docking or closed passages, the captains are relying on the information from other people, which might introduce some issues, especially in terms of communication. So the decision point is still 100% on the let's say on the human side. So in that sense, there are several issues maybe here that we would like to address. One is around the situation awareness. So not all the systems can, let's say, detect the objects, etc., etc., and also the cognitive load for the operator. Even if we look on the left-hand side picture, there is a lot of let's say screens and a lot of buttons and a lot of knobs, which might be a bit overwhelming when the situation gets critical, or when the operation actually requires a bit different, let's say, look and feel from the system. So we are also looking from that perspective, yeah, how to provide the information that are actually needed for the operator in the current, let's say, state that the operator is put on. So for instance, in case of some emergency braking or needed of docking, etc., we can actually adapt and provide the information that is suitable for the current state. And how we are, let's say, willing to do that. Yeah, so how we're willing to actually provide such a functionality. So as of now, we are relying on a couple of, let's say, systems from ABB. So we thought that the first stage that we should actually do in order to be able to flexibly fit into the needs of the customer is to focus on the functionality and the modularity. So actually, we started to take our systems that we have had developed, or that were, let's say, developed as a proof of concept, in order to chop them up into functionality modules. Yeah, so like end-to-end functionality modules. So the stage here for what we need to, let's say, do is to define the requirements for each functionality. So what kind of value it provides, what we need in terms of the sensing device, what we need in terms of the computational, and what we need in terms of the human-machine interface. Yes, so what the operators are or will be looking at the end, and they will then put their decision based on the feedback from from the system. And the second stage is the development based on those, let's say, need for application. So certain or different vessels have, of course, different operational profiles. They might carry the cargo, they might carry the people, they might carry actually both things. There might be smaller size, bigger size. So that's also the thing that we would like to address. Some of them will require some sort of cameras to improve the situation awareness for the captains. Some of them will not, because they will be so small that actually people sitting on the deck will be able to see with their eyes. On the other hand side, also going to the remote operation, we are very much interested in and working on what kind of information we need to provide to the operators that are outside of the vessel in order to give them, let's say, all the information that they need for safe operation. So the opportunities that we do have within the FOREMAST project to do so is, since we are collaborating on the Living Labs, which was introduced by Georgia, we are mainly contributing with the NIAC. So for us, the possibility of quick prototyping, that's quite a unique, let's say, feature, because usually in the seagoing vessels, there is not so much flexibility and not so much, let's say, availability of the vessel itself in order to, let's say, change some stuff or to add some new sensors. Also, in terms of commissioning and wiring, this is a bit easier for such a small ship. And we do have actually variety of the sensors and system that we can leverage or we can use and see how they will benefit into this, let's say, architecture that we are building. So by adding or deleting some of the sensors and some of the equipment, we can check how this will influence the operation and the situation awareness at the end. And also, maybe last but not least, if we are able to, let's say, develop certain end-to-end functionality as maybe as an ABB, for instance, I don't know, collision avoidance module. Yeah, so we have the information from the sensor, we have the calculation for the collision avoidance. We can actually, let's say, change the vendor of that collision avoidance. Maybe we can have collision avoidance system from the CFAR, which will be hooked up to the sensors from NIAC and then to the, let's say, human-machine interface from the ABB. So also we are very much looking into this modularity and interchangeability of the solutions, because we might not be the best in the class, or we might actually then integrate the functionality which is totally outside of our scope, but still will provide benefit to the operators. And that's contact to me if someone is willing to ask some questions or will have to, yeah, would like to catch up. That's my, let's say, contact points.
Very good. Thank you, Michal.
Thank you.
Yeah, definitely. You can reach out to all our presenters later on via LinkedIn or email. You can also use the chance now, use the chat, ask directly. As we heard now from the presenters, they are kind of interested in working together with other people, other organizations, trying to develop technology, or they build products together with others, so it's compatible, or they can see that it will have a use and it's not just developed to have it. And one person that I guess that's everyday life is working with all these technologies and seeing how to regulate them, or seeing what is important, or risk assessment. Jerome, I will hand over to you. Looking forward to your presentation. And you're not developing something per se within AUTOFLEX, but you're involved in the project. And yeah, thanks for being here today.
Thank you, Jonathan. Yes, indeed, in Bureau Veritas Marine and Offshore Division, we are working on autonomous shipping and remote operation for several years now. We have published our first guideline on autonomous shipping in 2017. And the target for Bureau Veritas Marine and Offshore is to build a regulatory framework and to help for this building at different levels. We are fully involved in the international development of regulatory framework. different level. We are involved in IMO as expert for French flag. We are following the development of the mass code. We are involved in the correspondent group and working group. And we are participating at each MSC. So we will be in London for the next MSC 110 in June. And we are working in the mass code. We are still on the road track, I would say, to publish this mass code on next mid-year next year on 2026. It will be a non-mandatory mass code, and yes, the target is to finish this mass code and to help the national flag authorities to implement and to apply this mass code. We are also at international level for maritime framework. We are also in the AIAX Safe Digital Transformation Panel. AIAX is the association of all classification society, and AIAX decided to establish a dedicated panel. What we call panel is a working group related to all digital matter. And this Safe Digital Transformation panel is working on the topics such as cybersecurity, autonomous shipping, and data quality, and so on. And the target is to publish common, unified interpretation, unified recommendation, and unified requirements on these different topics. We are also involved in the ISO development, and now there is a dedicated subcommittee, the SC26 committee in ISO, dealing with all topics related to smart shipping. And in this subcommittee, during the last meeting in Oslo 2 weeks ago, there were a lot of presentation of new work items related to autonomous shipping and remote operation. And ISO will develop a standard and technical specification for communication of maritime autonomous ship, for quality management, data quality management, for several topics related to mass will be dealt by this ISO subcommittee 26. Finally, for naval boat, of course, there are a lot of developments related to unmanned system and a small USV or bigger USV in the naval boat. So we are involved in the International Naval Safety Association, INSA, and we are working to draft a new dedicated chapter in the naval boat code to implement specific requirement related to unmanned system. For more regional, that was for the international level. For more regional statutory framework, we are also trying to follow all the regional or national development performed by the different flag authorities. At European level, we are in a good discussion and good collaboration with the European Commission representative in IMO, and we are working with them to formalize some input paper and to implement the result of coming from the different European projects and to implement this result in input paper for IMO to build the mass code. And we were involved in different European projects such as Novimar, Autoship, and now Seamless. Seamless is still in progress, and it's related to autonomous shipping, inshore shipping, and inland waterway also. For other regional framework, of course, there is a Nordic Memorandum of Understanding, the Nordic MOU, with several main flags in Europe. Of course, MC, Belgium, Danish, UK, Netherlands, Norway, and it was the first partner in this MOU, and France and Germany is in the process to join this MOU. And it's a very positive initiative because it will help to have a common framework, regulatory framework in these different flags, and it will help a lot all stakeholders. And of course, it will help also classification society because each time we have a project, we need to discuss with each separate flags, and if this MOU succeed to produce common regulatory framework, it will help a lot. I have also identified different flags that have already published dedicated guidance note or requirements, such as the Norwegian Maritime Authority, and they were the first that published a dedicated circular on 2020 related to unmanned and partially unmanned operation. UK also, Maritime Coast Guard Agency, have published an Annex 2 in their Warbird Code 3. And this Annex 2 is related to remotely operated unmanned vessel. And we are, as a classification society, Bureau Veritas is allowed to, is notified to issue a certificate based on this UK Warbird Code 3. And of course, we are closely involved in the France statutory framework development. They have published specific regulations related to mass and maritime drones. Maritime drones, they have defined some criteria to define what are what they call drones. Or it is a small USV, and we are finalizing technical regulatory rules that will explain what will be the technical specification and technical requirements related to these drones. And in Bureau Veritas side, we have two levels of technical offer. We propose for several years now approval in principle based on our guidance note NI 641. It's what we call approval in principle. It's a design review. So we receive document, and depending of the maturity of the project, we review these documents, and we list what all the items that are in line with our recommendation and what is not in line, and it's based on risk assessment. And for small USV, less than 500 gross tonnage, we are also able to propose classification. So in this case, we are performing a design review, but also survey during the construction, survey during the manufacturing of equipment, and test and simulation. And after the delivery, we still follow the unit during the ship in service. And the main part of this risk assessment is the risk assessment and technology assessment. This risk assessment is performed according to the 5 stage as described in our guidance note NI 641 section 2. And when the systems are not based on the qualified technology, we have also a dedicated other guidance note, the NI 525, to qualify this new technology. And all this risk assessment we can be performed also by our subsidiary Bureau Veritas Solution, and it could be involved at the customer request. We have performed this approval in principle and classification for several references for inland navigation or maritime shipping navigation for different clients such as CO, Lixail, for Japanese NYK Group and Ørsted in Denmark. And this approval in principle, each time we request to perform ASID, FNMECA, and different risk assessment session, we review all the documents, and we are dealing with different type of units, civil, military, inland and maritime, and different type of size and services. We have also performed an approval in principle for the communication system and the remote operation in collaboration with CIFAR also. So my key message is that the international statutory context for MAS and USV is still under construction, and the Bureau Veritas Marine Offshore Division is fully involved in this construction of international statutory framework. We have two technical offers to propose for all autonomous and remote operation projects, approved in principle based on our guidance note NI 641 and the classification based on a dedicated rule note NR 681. And also for the future, we are finalizing a dedicated guidance note on machine learning system, because we are more and more machine learning system on board ships, and we know that we will have to certify them. So we will publish in June or maybe beginning of July this year this new guidance note 692. Related to how to assess and certify a system based on machine learning. And we are still, of course, working on to implement and to improve our guidance on NI 641. The target is to publish a revision 2, maybe before the end of this year or beginning of next year. And the target is to consider and to implement all requirements coming from the MAS code in our NI 641 and to explain how to apply these IMO requirements. Thank you. Do not hesitate to contact me in parallel, or do not hesitate to ask questions now if you have a question related to Bureau Veritas classification matter. Thank you.
Thank you, Jerome. That was great. Got a good overview of what you're doing. You're involved in quite a different regulation processes and many projects. It's good to see. While Javier is preparing the next round of Slido, I would like to say thank you to all the presenters presenting here what you're doing within your organizations, but also, as part of these projects, FOREMAST and AUTOFLEX, and highlighting how important it is for you to work with others and reach out to people, develop something together, and have something that is actually working. Because as we are seeing and as we will be discussing just after the Slido, there is a lot to do. There are a lot of uncertainties. There is something that had never been experienced before, and not only the technology will change, but also the life for the people, or the things that we see when we're out there. Now it's time to wake up, everybody in the audience. I would be very happy if you could get out your phone again, or maybe log into slido.com, participate the next round. We have some questions that will guide the way to the discussion round that we're having in just a minute. We prepared some questions. We would like to hear your opinion, and I will hand over to Javier.
Let's start with the second round of questions. It's again three questions that I will share with you. I guess you had time enough to connect to Slido through the QR code or the code number here. So let's start with the first question. What do you think is the main barrier to larger scale deployment of autonomous barges in Europe? So far, lack of regulation, technology maturity to people. Let's see if we increase the number of response. Lack of regulation, it's on top so far. Someone is participating, just 3 people. So don't be shy and just reply to the question, please. For people, again, lack of regulation and technology maturity are the main barriers identified so far. Let's give 1 more minute to reply. In the meantime, I will go later on back to the questions. Now we have 83% for lack of regulation with 6 people, 7 people. Okay. So main barrier, lack of regulation and technology maturity, and some infrastructure gaps as well. Next question, which type of stakeholder should take the lead in driving the adoption of autonomous inland vessels? So far, national governments, industry logistic operators, and new institutions, as well as technology providers. So we have gathered now 11 responses. Industry logistic operators and national governments are the same level of interest. And last question, how can Europe position itself as a global leader in autonomous inland shipping? Harmonizing regulation, public-private cooperation, as well investing in infrastructure, funding large-scale pilots, and supporting SMEs and startups. So far, harmonizing regulation and public-private cooperation are the main responses that we have. So I guess that's all. Let's again for the beginning. Lack of regulation is the main barrier. In summary, industry logistic operators is the stakeholder that should take the lead. And regarding the position itself, in autonomous inland shipping is harmonizing regulation and public-private cooperation.
Okay, thanks for getting a glimpse of that. Thank you everybody in the audience for participating. Most of you attended. This is great. Thank you for that. And it sounds to me like there is a lot to do for MAS and DFDS as they're expecting to take the lead on that one, but also for Jerome. So you're working on rules, but it makes the impression that there is a lot more to do and some rules are not clarified yet, or there is something left to do. If you have any questions or you would like to give your opinion, maybe give some examples where you experienced, okay, I'm willing to do something, but there is no regulation about it, or I'm not so sure how to use it, or maybe you were denied to use something. We would like to hear from you. I would hand over to Odd Eric. We have about 45 minutes now. Yeah, we discussed the points that we touched upon, that we saw in the presentations. One thing that we saw that is the technology being developed comes with a certain risk, as some people are not really sure how to use it. Odd Eric, what would you say? What would be your first questions after you saw the presentation here today?
Thank you for handing over, Jonathan. There are some reflections from both from the Slido and from the presentations, but I can do the reflections from the presentations first. And after listening to all the presenters, I had one overarching question in the end. That is, how do we see the risk picture change when we introduce autonomy? Because Michel talked about cognitive load and these things, and how we can actually change the amount of information and how we operate the vessels. And I guess also CFAR with operational experience from remote operation, you might have some thoughts on that. So I don't know if any one of you want to answer to that, how you see the risks. Will there be new risks when we do remote operations compared to the conventional way of navigating? Yes, Maria, please.
Yeah, this is a really interesting question. I have many ideas. What are the new risks? The first one that comes to mind is the connection loss. So we have to secure our operations against this risk of losing the connectivity, because if you lose the connection, you can't have the control, and so the vessel is abandoned to itself, let's say. And then if you remove one or two people from the crew on board, how is the amount of work divided among the remaining people on board? So this is also to consider. Another thing is the role of the captain is the person is always on board. They're used to listen to the noise of the engines, to feel the wind on their skin. How does it change when they go into the office, and how can they have the feeling of and trust the technology in order to feel that they can really steer the vessel as they did before. So, yes, these are some questions.
Yeah, thank you, Maria. Interesting topics that we can elaborate on. But I see that Michelle also wants to say a few words. I see we also have a question in the chat. Let's do Michelle first, and then.
Okay, thanks. Yeah, so I mean, from my perspective, or from my experience for the seagoing vessels and the industry, usually we are starting with some risk already, that are hooked up to the actual operation. So maybe the operator isn't able to see what is happening around the vessel, or operators are not capable, let's say, of doing certain operations because it's like too heavy for one person to do, or they have to work synchronously. Yes, we need to call maybe a chief engineer to do some sort of certain activities on the vessel. And of course, those systems are very much distributed. So we are trying to cover, let's say, those risks, but I kind of like that you catch that while you're covering this, let's say, old regular risks that are hooked up to the operation, we are of course introducing like a new type of risks that as of now are a bit unknown. Maria was saying about the connectivity. Second, that is coming, let's say, to my mind, what if the automation or autonomy in certain areas will stop working? Then we still need to rely on the manual operation. And if we do not have a trained person in there, or the person are doing such stuff for the first time, also they might not be able to, let's say, handle the load of such operations. So also we are very much involved into learning, let's say, captains, and also in the simulation technology, so that we can actually, in a safe environment, put them into, let's say, critical situations, and then so that they can get used to handling this critical operations, or being a bit more trained to one more time hand over from the automation to regular, let's say, operations.
Yeah, thank you for your reflections. I think the part with handling situations when autonomy fails and the manual operation is one topic that needs to be elaborated on. I see that we have a question also in the chat related to what we're talking about, maybe before Mats goes ahead. So Stefan has a question: how secure is the technology on autonomous shipping regarding cybersecurity aspects? And that's a quite interesting question, because obviously when you are connected, you become more vulnerable to cybersecurity or cyber attacks and on these things. I don't know if there are anyone in let's call it the panel here that would like to say a few words on that.
Yes, I can.
Yes,
I can.
please.
Yes, I can say that of course, cybersecurity is identified as a very hot topic, and it's also an additional risk compared to the conventional vessel. Even if cybersecurity is important for conventional vessel, but for autonomous and remote operated unit, of course, cybersecurity is a very important topic, and we are manage it as a specific topic, and we have a dedicated part of risk assessment focused on cybersecurity. We try to implement unified requirements at IAX level for a conventional vessel. It will be at least a first layer, I would say, to assure that we have cybersecurity requirements and cybersecurity protection, but we know that this first layer is not enough for autonomous ship and remote operation. That's why we have higher class notation for autonomous vessel. We in Bureau Veritas we propose the notation cyber secure. It's more with additional requirements related to communication, to separation of different network, IT, OIT, and we are still working to develop dedicated class notation for autonomous shipping. So, and we also push these topics to IMO because for the time being, IMO is not doing a lot on cybersecurity. We have only quite common circular asking for a minimum risk consideration for cybersecurity, but we know that, and it's already identified in the mascot draft that cybersecurity is need to be addressed and is very important. So, but we will continue to work on it, and also for all the communication and connectivity between the ship and the rock. For example, we have clearly separate in the mass code the topic communication to the topic connectivity, and the connectivity between the ship and the rock and the other stakeholders need to be also dealt with during the mass code application.
Thank you, Jerome. Good to hear that this is high on the agenda, so for the mass code. We have a couple of hands. I think Alan, or how do I pronounce it?
Yeah. Good morning, everybody. I'm working on the teams with FOREMAST and represented NEAC. And we are working on these cybersecurities as a development work. But I want to point out already what was approached by Jerome, that cybersecurity is a very wide word for taking several aspects in consideration. Of course, there is the aspect of the cybersecurity of the equipment, and there is a lot of ongoing references and obligation for the equipment, but there is also the cybersecurities of the internal communication between these different equipment to take in consideration, and we are mainly working on that. And of course, there is also the cybersecurity of the attack, or the communication between the different boat, or the boat and the remote control, or the boat with the different other boats like the IS and so on. And we have also a lot of work on this aspect. And for example, the denial of attack when you are using some communication through the internet cloud has to be taken. So in fact, there is so much different topics within the world of cybersecurity that it has to be separate on the different precise topic, because it is a very, very key issue aspect if we want to go or to the remote control or even later one way on the full autonomous boat.
Yeah, thank you. A lot of good points there also on the internal communication between different equipments there. Certainly a lot of different aspects that we need to consider. I don't know, Michel, if you have anything to add to that.
Yeah, I very much I'm aligned with Alain, let's say, perspective. On top of that, one thing I wanted also maybe to mention, after, let's say, developing or delivering the solution, we still need to think about the maintenance. Yeah, to keep the software, let's say, updated, and then to fix main, let's say, main cybersecurity threats if some will be found, like day zero or something like this. We need to then also react upon those in order to keep our vessels secure. So it's also a bit of a challenge how to do this for the vessels that are already in the operation.
Yeah, good point. So an add-on to the maintenance scheme with the more software focus as such. Thank you. I also see there's an interesting question from related to this from Sifis in the chat. I can read it, or you can also read it out loud if you like, Sifis. Prefer to
I could also, perhaps say a couple of words, and also in some risk assessments that we've done, and of course, so far we've only assessed projects separately, but we end up talking about one rock controlling a lot of, or that may control several ships, and I think at some point need to discuss about the single point of failure that we're introducing in the rock and how to resolve it and what kind of measures we need to adopt and how to also regulate it. I think Jerome correctly, and correct me if I'm wrong, but I don't think this is something tackled in the mass code at the moment. But we are concerned about this. That's the point of it. That if we end up having a rock with 20 ships, that rock failing for whatever reason can result in a high risk situation. And we're not saying that we will lose control of the ships, but we might end up in fallback states for 20 ships at the same time, which is a significant increase in risk, and we are concerned about that. Thank you.
Indeed.
Yeah.
Just to mention that, so we are not working on this specific scenario, but in seamless project we have trying to test and to demonstration one rock with 3 ships, but it will be 3 ships of the same company, so it will help also. But it is the first step following because all the main demonstration performed now is one rock, one ship, and it's quite easy. But when you implement more than one ship during the demonstration, you have a new additional risk. But as you said, when we will have a lot of ships from a different company and a single rock, of course, we will need redundancy on rock and yes, a lot of other risks to be analyzed. Yes, and we will have also to manage several flags on the national authorities.
Many interesting challenges there.
Yes,
indeed. I don't know, Maria, do you have any things to add on to that? In case you have a single failure that applies to several vessels simultaneously from a rock perspective, how we can deal with this kind of situation?
This is a very good point that we're asking internally ourselves. And I know that we're investigating this aspect of cybersecurity on the equipment, on the connectivity, and at ROC level. But for now, I don't have an answer. It's really something that we're working on it.
Good to hear that it's being worked with. I think there's a lot of interesting follow-up questions for that. But we have also more questions in the chat, and if start at the top of the chat, we have does your project or any of the partnering organizations considering stakeholders collaboration issue on way to implementing further automation in water and within the associated operation? So if I understand the question, is how, if we look at how we can, the different stakeholders together can work on implementing the kind of the ecosystem of automation, so the combination of the ship and infrastructure. I don't know if that is correctly interpreted, Rana, or if you want to add on to something there. but I can.
So maybe we can direct the question to the respective project coordinators. So maybe Georgia or
Yeah.
Derek, you can say something about your experience. So when reaching out to other people or introducing the concept of autonomy within, logistics, what is your experience when reaching out? Because for some people it might be a new thing or it's unheard of. I guess, Mas, maybe you can also share something about it. You're active in these project as an industry partner, but maybe from the perspective of the FOREMAST project. So, Georgia, are there any difficulties reaching out and engaging people?
From our side, especially for the Living Lab 1 in Ghent, we had some interviews with local people there, and they were quite, excited about this. So we start having interviews and trying to cooperate with them. So it was quite good. On the other hand, there are some people that are a little bit more reluctant, let's say. But I think we will get there at some point. It's mixed, to be honest. So, yeah.
Okay, so different experiences, but definitely some people were enthusiastic about it, or they wanted to work on that and develop something new.
We have cooperated with them, yes.
That sounds good. How about the AUTOFLEX project, Eric? How is your experience there?
We are trying to address this also in the project in terms of combining the, and I'd say maybe also at the same time I can take the question from Lars Andreas here. He has a question on how our vessels. We say that our vessels are flexible, so how they are intended to be used to improve the flexibility of waterway transport. So that's how I see it, that it becomes more flexible because you look at not only the vessels and the technology of the vessels, but also about the operation of them and how they fit into the infrastructure that you need to put into play, and also how the different stakeholders, like you mentioned Mats here, with logistics operators and how they work together with also the operators of infrastructure. So how we see the flexibility as such is related to we build a small vessel that is not so depending on human capacity on the vessel, but rather on a remote operation center that can download, let's say, a mission to that vessel, and it operates in between different keys and between the factory and the customer directly through the transport systems our concept we are working on in the project. How I had this becomes a very generic answer.
Andreas, calling from the moon, you turned on your camera. Is there anything you would like to add?
Yeah. No, I think that first of all, my name is Lars Andreas. I'm from Sintef Ocean, a colleague of Derek. And thank you for all these nice presentations today. When I heard Derek speak and Georgia speak in the beginning about the scope of those two projects, and further when Mats presented the drivers of what I remember was automated transport, flexibility was one of those drivers, and Georgia also mentioned this flexibility in the FOREMAST project, and it goes without saying in the project name of AUTOFLEX that flexibility has some part there. So I think my question was that when we see these vessels that have been designed and are being retrofitted or redesigned in FOREMAST, except from the zero emission part and the automated part, is it the vessel itself that is flexible, or should it bring some flexibility to transport in a positive manner? And I was wondering how you plan to tackle this. I guess that my understanding about flexibility is both, it could be vessel-centric, but it's more in terms of competing with more flexible road transport, or making waterborne transport more flexible. Or, yeah, that was my general question.
Okay.
Thanks for the question.
I think
Georgia, yeah.
I think this can be answered actually because Alan is here from the NEAC Living Lab, and this is the work that they are doing with Michal as well. If they can give us their feedback on this one, I think it would be more useful for everybody. To be honest, we have the user here, let's say.
I cannot see if Alan is still with
okay.
us, but I mean, for the flexibility aspect, we, at least at the first stage, we heavily concentrated on the design. So how we can actually decrease the capacity of the vessels, increase maybe the distance that the vessels can go with certain cargo, or actually accommodate for very specific, let's say, cargo space. So that's on, let's say, flexibility in terms of on the vessel hull or on the design of the vessel itself. Second is, of course, the propulsion and power energy management system. If we can, for instance, adapt to the operation, to go from the batteries to the hydrogen without sacrificing the cargo space or without sacrificing the energy efficiency. That's the second one. If we can somehow exchange the energy source components as well, or we can charge as we go on certain stops. So that's also, let's say, being considered as this, let's say, flexible part, and from our, let's say, ABB scope is this flexibility in terms of functionality and the feature sets that we can somehow deliver, not by delivering yet another hardware which will then eat up the cargo space or will require extensive reduction in cargo space and increased energy, etc. It's more like on the functionality. So whenever certain functions will be required for operation, to be able to somehow either build it on top of the install base, either with a minimum footprint added to add them as a value. So at least this is from my side and how I see this flexibility in our project.
Yeah, thank you, Michal. Rana, did you have your hand raised at some point here when we discussed your question?
Yes, I will just add to what says Michael, that in fact, this is one of the...
Rana first, please, Alan.
Yeah, I can speak it. Sorry, I mean, for my background noise. So what I was saying that, yes, it's more about like if a stakeholder can collaborate, actively. So I mean, not the people who are here. It's more about the people who are who have to implement it. Are any one of you investigating how they can collaborate, how to facilitate them collaborating? For example, different stakeholder, how they can collaborate if someone is focusing on that also. So it's very non-technical part. If anyone focusing then. That was my question. Thank you.
Thank you. It's a very good question. I don't know if Georgia want to go first, or I can. We have it in AUTOFLEX. We have. Sorry, Alain.
Yes, I was just wondering to add something more from what said Michael. In fact, with the very small vessels like the SFAS studies, the concept of the flexibilities is also given by the swarm activities. So it is different small boat who can exchange mission or can exchange subject to solve, and how this could be treated. In fact, the idea is to go with small vessels is like the development which has been made in the logistic with small vehicles like bicycles or cargo vessels, where you have a very increased the flexibilities by reducing the load to transport, but you compensate by many small vessels who can discuss and reorganize their logistic activities.
Thank you. Very, very good answer, I would say. I can only second to that in terms of the AUTOFLEX project as well. To go back to Rana's question about how to actively collaborate with stakeholders outside of the project, maybe as Javier, do you have some thoughts there? Since you may be working more in that area.
Well, first of all, we can maybe explain about the Inland Waterway Platform task force that has been organized under Platina for Action project. So we, AUTOFLEX and FOREMAST, we are both members of this task force. So I would say that it's gathering, I don't know how many projects, but 20, 30 projects related to inland waterway transport. So we have meetings regularly, so there is a good platform to collaborate with other stakeholders. Inside FOREMAST as well, we have created another under the umbrella of the Inland Waterway Platform, task force. We have developed on our specific task force focused on inland waterway transport and short sea shipping. So I would say that this is the best way to collaborate with all stakeholders that are interested in inland waterway transport. So I don't know if I replied to your question, Rana, but we are actively collaborating with other stakeholders.
Thank you, Javier. Good that you mentioned the IVT projects platform, and that could also be included in information about that in the chat for those who are interested. Maybe. I had a question, and then I completely forgot about it.
And maybe take your time to think about it, because I too have a question. I would like to pick up on the flexibility of transport systems and maybe ask Mas about his opinion, because you're seeing it from a logistics provider, and during your presentation you were mentioning, yeah, we are transporting stuff. We're moving goods from A to B. Not really care too much how it's done, at least as it's done. So maybe talk a little about why are you engaged in automation and automated processes? How will it help the flexibility that was mentioned here?
Yeah, maybe starting taking one step back. A lot of our trailers on the roads are running around empty for up to 40%. And these empty runnings is basically a product of how we move things today, that the evaluation criteria from customers are often it's the price, it's the speed, and it's the performance. So if you take the speed, then it's fast as possible. Back to human nature, we are super impatient in general. 30% of our emissions is due to that in several surveys. But if we have more flexibility in the network, if we can perform a mission, if we call it a mission or a move of a cargo unit at any time in a 3-day period or whatever, and not necessarily fast as possible, we will be able to make the kind of the transport network work more smoothly with less impact, less energy that we need to consume, and less empty runnings. That is kind of the basic notion of this. And the automated units make it possible to use whatever time during the day. It's not within office hours. It's not when a person is available. It's when the asset is empty or available to take cargo. So that is kind of the flexibility that we try to introduce, kind of overall, if being a truck or being a inland barge or being a rail or short sea ship or whatever. Maybe also taking it 2 steps back to the kind of the risk. I see it, there's a risk in kind of the automation of networks and assets in general, but I see the risk for society not being able to move goods, not being able to perform as large, and something that we need to consider. We have a 20-25% increase in volumes that need to be transported. We have already now have a lack of personnel to do that, and we see countries around the world starting to to ease it a bit on regulation and demand on these autonomous systems being introduced to actually make up for lack of people. Japan is a really good example, and I think that is kind of our motivation in this project as well. We need to make this work, and we need to kind of speed up the process as well. Being able to perform that, there would be a report from ITF being published on Wednesday, and the numbers are, I believe they will just go up and up on kind of workforce availability. So that is another risk that we need to consider, together with all the rest, of course. But yeah, that was a long answer, but yeah.
That's why we're here, taking our time and diving deep into some questions. And I guess Lars, Andreas, you have something to add here?
Yeah, thank you, Mats, for that reflection. I think it was very nice. So just to check if I understood it correctly. So what you would like is more flexibility in the logistics network to decide whether you would like a window where you can send the goods ±3 days or something like that, which would be your business and customer part of the transport system. And then I guess that to be able to use the automated units, which are, you could say, less flexible, then we would need some sort of support from local authorities to make the infrastructure ready. So it's back to the survey, perhaps, that it is the business side compared with the need for authority approvals to install infrastructure. That is the real challenge, to make it work in a flexible manner.
Okay, so we're back to stakeholder engagement. Maybe so we as a project cannot invest in the infrastructure. So that would also be maybe what we saw from the Slido, that national governments also need to work on that and make some the boundary conditions work on that, so that it is possible to do so. So far, I don't see any other questions in the chat, so I would like to continue maybe a little bit with the human factor. So in future, when all these things are automated, and then maybe something is always in the air that is, we're working on to make other people lose their jobs, which might not be necessarily true, because there will be new jobs created. So my question to the presenters: how will the skill set change in the future when we say, okay, the seafarer will be involved using some technology that maybe he or she needs to learn? What other skills are necessary in the future?
I think that's a very good question. I don't know if I do have answer what kind of skill set for the operator will be needed. However, we see that those are, let's say, changing. Also having or running the studies together with the captains that tend to use the systems or the previous systems for like 20+ years, being, let's say, used to hitting the buttons that are clicky in terms of the functionality, that they are used to blinking for the buttons, that they are used to having all those knobs and joysticks. And now we are shifting a bit more to, okay, they are maybe having the same joysticks, but they are looking on the vessel from the remote center, or they are even do not touching the actual equipment on there, or they are doing steering by having a touch screen. So it might be different. However, for me, it's hard to, let's say, judge what would be needed from them. I think we'll see how the market will actually shape, and what will be preferred way of controlling the vessel, both from remote and on board. And then maybe we can see how all those new technologies can shift the market, if they can actually support in the recruitment process, so the more people will be interested in such a job, or vice versa. So
Thank you, Micha, for that. It's kind of similar to what Maria already has been mentioning. So usually people on board, they were feeling wind in their face. So this was something like real haptic experience. Maybe Maria, you are in touch with people working in these remote control centers. Have you heard anything from them? How is their life different now, and how is their job totally different? Have you heard of them? Did they need any new skills that they developed throughout the time being at CFAR?
Yes, well, I know that they're happy that they can spend their evenings at home. This is one thing. For example, we have one operator. This is he's 30 years old, and he has two babies, two kids of less than 5 years old. So for him, having the opportunity to be a father from the beginning in their early years and be with them every evening is really added value. From a skill set point of view, I would say that of course they need to learn how to use the software, so the human-machine interface. They have to learn to follow the procedures that we define in order to take control and hand over control in a safe manner. And then, yes, of course, be able to understand that the commands they give through the human-machine interface are actually taking place on board. So this is a link that they have to develop and to strengthen too. On this matter, on this topic, we're also collaborating with a researcher from University of Erasmus, if I am correctly. The Erasmus School of Social and Behavioral Sciences, and she will answering some questions that are part of this big question that you just asked. So how do remote operators learn navigation without the senses, and how does remote control change the kinds of skills and knowledge needed to navigate a vessel? Also, how does moving from ship to shore affect remote operators' feelings and perceptions about their professional identity and so on? So it's something that we are facing head-on, and I will be very curious personally to read her article and her publication.
Okay, thank you, Maria, for sharing your real-life experience. Maybe Sifis has something to add to that?
I can try, at least from our experience with dealing with rock operators, and in general, talking to the people and to rock operators, I would say that our experience is similar to what Maria reported regarding especially their work-life balance and the benefit of that to remote operators. What I would say to that, however, is perhaps that we should also be cautious about, at least us as an administration, of the geopolitics of this, because I mean, what we also need to address eventually is that, sure, this is the case, especially in Europe, where we also see in some areas lack of seafarers, and this is a good way of solving it. At the same time, there are other places in the world where this is not the case, and definitely also at IMO we do see some member states being concerned, and these are seafaring nations which are concerned about eventually the whole business model at the end of autonomous ships, and how that will influence their jobs. Regarding the competencies that we see, in addition to also what Maria said, and there are a lot of studies that some of them have already concluded, some others are ongoing. What I would only add is perhaps that some studies have identified the role of a sort of fleet manager, and training a person to have that sort of role that is separate from a directly remote operator. And where, again, this is my ignorance in relation to inland waterways, but what is an interesting question that comes up to us, at least, is also the question of because in maritime you need to have like at sea experience to maintain your certificate of competency. So practically, in order to maintain your certificate, you have to have seafaring experience, and whether that is equivalent. So we get the question whether rock experience is like being at sea, and eventually we also have gotten recently the question on whether rock experience could also qualify as sort of from, let's say, from being a cadet and having training as a cadet to eventually reaching higher competencies. And again, this is not exactly my field, but we are getting questions in relation to that. Thank you.
Thank you. Thank you for your insights. I guess, yeah, you raised some questions that are valid and they're out there, and it's hard to answer them today, or maybe impossible. But it's something that we should work on and then we should look out to. And I don't know about your teams, but mine notified me that there is only 5 minutes left in the meeting, so we're almost done here. And I don't want to keep you from your lunch break or any other appointments that you have for starting at 12 or later. So yeah, we're coming to a closing round already. I would like to take another look again at the AUTOFLEX key exploitable results, because this is something that we have on our agenda in AUTOFLEX. So not only are we working on a more flexible transport system where we're trying to include many stakeholders and trying to come up with the system that is more than the vessel itself, but also we're trying to look at new business cases or new business plans. So this is why we have DFDS on board. We're trying to take a look at how could business be working and still continue in the future if we have this automated processes. And cybersecurity is also a topic within the AUTOFLEX project, developing the Seaguard tool, detecting anomalies during the ship operation, and trying to be aware of all this. And AUTOFLEX in a nutshell, I guess, here on that slide. I will now ask FOREMAST to present their key exploitable results to see what they have in pipeline for their project. Maybe Javier, you want to say something to that?
Yes, of course. You can see my screen, right?
That's it.
Yeah. So I will be really brief introducing the key exploitable results. These are the organizing 3 functional modules that together support this vast vessel. So we have the module 1, that is the SFAS components. This includes the technical building blocks required to equip vessel for SFAS operation, like Care 1, 2, and 3. As I have just 2 minutes, I will go really fast. So then we have module 2. This is digitalization, that is FOREMAST digital twin platform, data space, and toolkits. This module is focused on the digital infrastructure, enable automation and optimize performance. So here, all the cares are feeding the Care 4, that is the digital twin platform for SFAS vessel design. So virtual model of vessel used to design and test performance without needing physical prototypes. And finally, the module 3, that is the SFAS adoption. This focus on the wider system level deployment, planning, and business innovation. So we have the Care 10 FOREMAST solution blueprints and the Care 11 urban inland shipping service concepts and business models. So that's from my side.
Quick and brief. Thank you, Javier. I would like to say thank you to everybody here in the audience today for participating, asking your questions. I hope you find that useful. I hope you like the format where you can reach out to people directly. Let us know in the comments, maybe on LinkedIn later on, or reach out and tell us personally. You can reach us via email or Teams or LinkedIn, the usual channels. I would like to say thank you to Maria and Georgia, to Javier, to Jerome, to Mats, to Michael, and to Eric for being here today, taking the time. We are offline now, but let's stay in touch. Let's stay connected. I mentioned often enough where you can reach us, and I hope to hear from you soon again. Thank you and bye-bye.
Thank
you very
you.
much.
Thank you,
Jonathan. Bye bye.
Thank you. Thank you, everybody. Bye.